Okay, so let's have a look at noise pollution and how mines can mitigate against it. So, if we have our open cast mine doing their normal thing, and we've got our trucks driving around down there, and we've got some blasting going on. Obviously, this truck's left it a little bit late before it left. Um, so these are our main sources of noise. What we can do is create embankments around the edge of a mine, between the mine and any nearby sensitive receptors, like houses with poor old Miss Miggins living in it still, or something like that. So these embankments are also sometimes called baffle mounds. Help to absorb and deflect the noise um, that is produced by these noisy activities. The other thing we can do is have a timetable when blasting can take place. And this would be sort of published so people know when it's going to take place. It doesn't come as a surprise. Um, so this avoids it being unexpected. Which is particularly disruptive. And it would also be during daylight hours, not at night when people might be expected to be asleep. So this helps prevent it causing a nuisance to neighbours. Next one then is turbid drainage water. So if we have, for example, a China Clay Works, which is usually a big open cast mine, um, but it could be any type of mine, to be honest. These are particularly at risk because they use water to blast the China clay off of the side of um, the mine, and that's obviously going to then produce a lot of um, water that's going to have a lot of suspended solids into it. But any mine where it's got water flowing over it has the potential for turbid mine drainage as well. What way we can mitigate this is to have a sedimentation lagoon. So we build a catchment lagoon, sort of with an embankment to retain the water. The water is kept inside of it, and this will be retained for long enough. So this is a sedimentation lagoon. So this has a long retention, and this will permit solids to settle and sink, and then the discharge to a nearby watercourse is therefore going to be low turbidity. And this is a very common technique that you'll see for lots of mines, but particularly China clay is a good example. Next one then is spoil disposal. So if you remember, we had aesthetics. So our aesthetics, what we can do for our spoil heap, instead of having a really artificial looking steep sided mound with no vegetation on, a contrasting color. This is no good. That's not going to work. What we can do is landscape it so it is a much more gentle shape. We can revegetate it by planting trees to disguise some of the contours. We can translocate soil, like have a covering of topsoil over the top of it to allow grasses to grow onto it. Perhaps we would break up the outline by using some of our larger overburden, like boulder, to provide some like scree on the outside edges. So this landscaping and revegetation are how we can improve the aesthetics, make it look more natural and blend into the landscape much more effectively. Next one then is we have stability. So this is usually done by reducing the gradient again. So instead of having this really steep, unstable, unconsolidated stockpile of overburden, what we can do is have a much more gentle shape. So a gentle slope. And we can add topsoil so this means that we have things like nutrients and organic matter, and this will allow plants to colonize it or might be seeded onto it directly. And we might use some trees to provide more consolidation and use the roots of all this vegetation to help retain this unstable, otherwise unstable material. So vegetation, roots prevent erosion and movement. And the last one then to do with our stockpiles is leachate. So what we can do is if we have a stockpile and it's got our sulfates and our toxic metals, perhaps it's arsenic, perhaps it's lead, whatever it is. And this is being leached out from our stockpile. We can pass this leachate through a bed of limestone chips. So this presumes that we've collected it somehow, prevented it from escaping into the wider environment. So we have some sort of leachate collection system. It's passed into this bed of limestone chips, which raises the pH. So it's no longer acidic, and the metals will precipitate out of solution because they're only mobile if it's acidic. And then we immobilize it. So the heavy metals are going to be immobilized. The sulfates and the sulfuric acid that's generated will be neutralized. Immobilized. And the water can then be discharged to local watercourses, and it's not going to be so harsh. The other thing we can do is provide a cap over the top. Cap stockpile to prevent water ingress in the first place. Easier said than done sometimes. If this is a particularly large stockpile or pile of spoil or something like that, it's going to be incredibly expensive to provide an impermeable barrier. So that might not be practical, but that would be ideal. And then the last thing we need to talk about is mine site restoration. So this is where we find new uses for old mining sites. We have to consider location, access to it. Is it somewhere that people can get to or not? Topography, so the shape of the land and what the site looks like, and residual problems, things like spoil heaps and toxic wastes or contaminated land. Okay, so for example, clay, gravel, sand, pits. So these are quarries that use for these. These are often flooded and developed into wetland wildlife reserves. And these are actually quite common in the UK. There's quite a few around if you know where to look for them. Urban development might be possible. But this is only possible if the ground is stable. So it doesn't have like a mine that might open up underneath of it. And if there's metal wastes, it might be more appropriate to do some sort of industrial use rather than residential, because that would increase the exposure to the locals. So this is something that happens in Cornwall quite a lot around historic mining sites. And agriculture is potentially possible. But this is dependent on the steepness of the land. If it's too steep, then you're not going to be able to do it because the tractors will roll off. Toxic metals to prevent accumulation within the human food chain, and soil fertility. Is it fertile enough to accept crops and things like that?